r equal to 0, the equation becomes what? Coefficient of x power 2, that is 2 into k minus n into a naught equal to 0. But a naught is not equal to 0. But a naught but a naught is not equal to 0. So this becomes, therefore, k becomes equal to, in this case, k equal to n. That is the first answer. K equal to n. In the second case, we have used r equal to 1. When you substitute r equal to 1 in the above equations, we see that we get the coefficient of, this is nothing but when we are comparing the coefficient of, actually this is the coefficient of x power k. X power k. Of course, we are comparing this with x power k. Here, when you compare the coefficient of x power k minus 1, x power k minus 1. So the above equation reduces to the form, actually, it reduces to the form 2a1. So when you compare this, here previously it was x power k only. Now we are going to compare x power k minus 1. Then the above equation becomes 2 times a1 instead of ar. Now it becomes a1. What is the coefficient? The first term, k minus r minus n. That becomes k minus 1 minus n. K minus r, that is minus 1 minus n equal to 0. Because when you put by the previous case, the second term vanishes, k minus r minus 1. K minus 1 minus 1, that becomes equal to 0. So we get only one term. K equal to n, even if you substitute k equal to n, still we get k is equal to n, even if you replace k is equal to, this is still not equal to, this term is not equal to 0. This term is not equal to 0. So definitely we should get what is called a1 equal to 0. So this is the answer. So if you observe in the first case, when r equal to 1, we are getting this value. The coefficient a1 term in the series, this term is becoming 0. Now we are going to consider the third case, that is when r equal to r only. So when you consider r equal to r only, we are going to compare the coefficient of x power k minus r. So we are going to compare the coefficient of x power k minus r. We are going to consider. So in the first case, x power k. In the second case, x power k minus 1. In the third case, we are going to consider x power k minus r. Then the equation reduces to the form 2ar into 2ar into k minus r minus n, k minus r minus n, and then we are having minus that is a k minus r minus n minus, if you observe, in order to get in the second term x power k minus r should be replaced by r minus 2. Then only we will get r minus 2, r coefficient, x power k minus r coefficient. So when r becomes r minus 2, we get k minus r minus k minus r plus 2 into, we are having k minus r plus 1. Equal to 0. So now we can calculate what is r. R is nothing but, we are going to take this term to the other side. We will get k minus r plus 2 into k minus r plus 1 divided by k minus 2 times k minus r minus 1. So finally we get this term, that is, so ar equal to, I'm going to write it here, ar equal to, what is that? K minus r plus 1, we start with smaller value, k minus r plus 1 into k minus r plus 2, k minus r plus 2 whole divided by divided by 2 times k minus k minus r minus n into, this becomes ar minus 2. Ar minus 2. So this is a recursive relation. But in the first case, what is the value that we got? What is the value that we got? K equal to n. In the second case, we got a1 equal to 0. And in the third case, we got a relation between ar and ar minus 2. What is the relation? Ar becomes equal to k minus r plus 1 into k minus r plus 2 whole divided by 2 into k minus r minus n times ar minus 2. This is how we got. So in this way, we are going to calculate what are the further coefficients. We got a1 equal to 0. So we are going to find out what is a1, what is a2, what is a3, what is a4, and so on. And finally, substituting those values in the given equation, we get the required equation. So what are they? That we are going to see now. For k equal to n, we got for k equal to n. For k equal to n, we have, in the first case, we are having that. So what is that? If you substitute that value in the equation, then we are getting, what is here? Just now I have written. What is here? AR equal to AR. AR equal to K minus R plus 1. K minus R plus 1. Once again, I'm writing. Afterwards, I'm going to substitute here. Into, what is the next term? K minus R plus 2. K minus R plus 2 whole divided by 2 into, we are having K minus R minus M, K minus R minus M into, we are having, that is AR minus 2. When K equal to N, so put K is equal to N here, then this becomes actually, that is equal to K. I'm going to, instead of K, I'm going to write N minus R plus 1 into, instead of K, what is that? N minus R plus 2 whole divided by 2 into, this becomes N minus R minus N times A R minus R minus. I hope that is clear. So this N and, so this, both the terms get vanished. So this term will be vanished and this term will be vanished. So what do you get? Minus 2R we are getting. So this is going to be the final answer. That is AR equal to finally we have to remember this. It is nothing but N minus R, N minus R plus 1 into N minus R plus 2 whole divided by minus 2R into A R minus. This is the relation between AR and AR minus 2. So first case we have seen when K equal to N. When K equal to N, we got this answer, that is AR equal to of this answer. Now we will see first case over. When R equal to 2, because R equal to 1, we got the answer. So when R equal to, I'm going to consider when R equal to 2, I'm going to write R equal to, another case, R equal to, when R becomes equal to 2, what is this value? A2 equal to, now we are multiplying, that is N minus 2 plus 1. minus 2 plus 1, that becomes minus 1. So that becomes n minus 1. And what is going to be the next term? That is n minus 2 plus 2. Minus 2 plus 2 becomes only 0. So into n whole divided by, that is minus 2r. Minus 2 into 2. Minus 2 into what is this value? A r minus 2. R equal to 2. 2 minus 2, 0. So this is, so A naught equal to, that becomes equal to this value. And when r equal to 3, okay, now r equal to 3, let us substitute in r value equal to 3 in this equation. What do you get? A3 equal to, so A3 equal to n minus 3 plus 1. Minus 3 plus 1 means minus 2. Minus 3 plus 1, that becomes minus 2. N minus 2. N minus 2 into, what is this term? N minus 3 plus 2. That means n minus 1. N minus 1 whole divided by minus 2 into, what is our value is 3, into A r minus 2, that is 3 minus 2. That means 3 minus 2 means 1, A1. It reduces to A1. But what is A1? A1 equal to 0. So this entire value A3 also becomes equal to 0. So finally we conclude A3 equal to 0. A3 equal to 0. So we got the value for A2, and A3 value again it has become equal to 0. Next we are going to find out what is the value for A4. When r equal to 4. So in this way we are going to calculate r equal to 4. When r equal to 4, this becomes A4. A4. What is A4? Once again, let us come back to the previous table. A4 equal to n minus 4 plus 1. That means n minus 4 plus 1, n minus 3 into n minus 4 plus 2 minus 2. N minus 3 into n minus 2 divided by minus 2 into 4. So that becomes n minus 3 into n minus 2 whole divided by minus 2 into minus 2 into 2r, that is minus 2 into 4 into a r minus 2, that means a4 minus 2, that becomes a2. But already we have calculated what is a2. So we are going to substitute that value here. That becomes n minus 3 into n minus 2 n minus 2 n minus 2 whole divided by minus 2 into 4. But what is A2? A2 we have calculated already. What is A2 value? A2 is given by n minus 1 into n by minus 2 into 2. N minus 1 into n. So it is, we are getting some pattern. Are you observing? Minus 2 into, that is into 3 into, that becomes A0. A0. We can redefine and we can say When it is 4 or equal to 4, 2 times we are getting minus into minus. So we can write this as like this, A4. In the numerator, we are getting 4 factors. What are they? N minus 3, N minus 3, and then N minus 2, N minus 3, N minus 2 into N minus 1 into N. 4 terms are there, 4 factors starting from N3, N minus 3, N minus 2, N minus 1 into N. Or we can also write N into N minus 1 into N minus 2 into N minus 3, like that also we can write. What do you say? I'm going to rewrite like this. N into N minus 1 into N minus 2 into N minus 3 is 1 later. So N into, I'll write this as N minus 1 into N minus 2 into N minus 3 whole divided by. So starting with N, it goes with 4 times. So minus 1 whole square. I can write this as minus 1 whole square into 4 can be written as 2 square. Okay, so 2 square and what is A2? Minus 2 into 2. By mistake, I have written here 3. This is 2 only. So we get 2 square. Again, we can write this as 2 into 4. Okay, so here also we are getting, otherwise we will get confused with the points. We can write this, we can treat this as 2 square into 2 into 4 into A0. So in this way we can continue and we can see that A1, A3, A5, etc. are becoming zeros, whereas we are getting A2, A4, A6. We will get only the even terms. Okay, substituting all these in the given equation, we will get the solution of this. Okay, so we can do substituting all values in equation 2, substituting all these equations in equation number 2, we get what is equation number 2? Summation. That is a general equation. What is the solution? Y equal to, we have taken in the beginning. What is y? Y equal to, I have written y equal to, what is y? Y equal to summation AR into x power k minus r. R running from 0 to infinity. 0 to infinity. So when you expand that, what do you get? That is y equal to, what do you get? Y equal to, what is first one? R equal to 0. So that becomes A0 into x power k minus r. What is k? K is n. So n, x power n, A0 x power n plus A1 has become 0 actually. Anyway, I'm going to write expand. When r equal to 1, this becomes A1 into x power n minus 1 And the next one plus a2 into x power n minus 2 plus a3 into x power n minus 4, sorry, n minus 3, n minus 3 plus a4 into x power n minus 4, n minus 4 plus 1. But already we are having, but what is a1? 0, a3? 0, but a1 equal to a3 equal to a5 equal to, all these are all zeros. So the other equation reduces to the form that is y equal to, simply this is a naught, we get only even terms, x power n plus a2 times x power n minus 2 plus a4 times x power n minus 4 plus etc. Okay. So already we have calculated the coefficients. So what is it? So y equal to, this is a naught, as it is a naught only, a naught into x power n. But what is a2? We have calculated. What is a2? a2 minus term we are getting. That means alternatively plus minus plus minus. So a2 can be written as n into n minus 1 divided by 2 power 1 into 2 into n. So we can write this as minus n into n minus 1 whole divided by 2 into 2. 2 into 2 into a naught. 2 into 2 times a naught plus, what is a4? Once again, we will get 4 terms. What are they? N into n minus 1 into n minus 2 into n minus 3 whole divided by 2 square into, so previously 2 terms, but here we get 2 square into 2 into 4 we get, okay, times a naught. So once again we will get alternatively plus minus and so on. I hope that is clear. So in every term we are getting a naught. So y can be finally written as y equal to a naught into, we can open the bracket. Here at twist, actually this is x power n minus 2. Here we are missing x power n minus 2. Here we get x power n minus 4. Okay, so this becomes x power n minus n into n minus 1 n into n minus 1 n into n minus 1 divided by 2 into 2 into x power n minus 2 plus n into n minus 1 n into n minus 1 into n minus 2 n minus 2 into n minus 3 n minus 3 whole divided by 2 square into 2 into 4 into x power n minus 4 minus etc. We get like this. I'm going to stop it here. I hope this is clear. Okay, in this way we can find the solutions. I hope that is clear. Okay, thank you.